Okay, thank you for your patience. So we're going to get started for today's webinar. Again, welcome. My name is Dennis Chai. I will be presenting today with my colleague Prasan, and the topic will be advanced inspection solutions for wind tower wells. So this will be the agenda. First, we're going to discuss about the wind tower construction market trends. Then we're going to continue on to the primary inspection techniques and challenges faced. Next would be the wind tower inspection offerings from us. And finally, we're going to have an in-depth look on the well site software. We're going to have a demo on the functionalities. Okay, first, wind tower market. Okay, I think everybody knows that the wind tower projects in around the Asia Pacific region is growing at a pretty significant pace. The Asia Pac region actually holds about 46% of the global offshore wind projects, of which 24% are in China. So the project trends actually show a tenfold increase in the production capacities from 2019 to 2024. And the Chinese offshore wind leads the region with 52% or 166 of the projects in this region. So the pace of development is also accelerating in other APEC nations, especially with significant numbers in countries like Japan, Korea, Taiwan, and followed by Vietnam. And overall, there are about 68 gigawatt of gas-fired capacity, which are under construction, led by China, India, Australia, and Japan in terms of capacity. And there's another 264 gigawatts, which are in pre-construction planning. Again, most of them will be in China, but we also have them in Indonesia, Australia, Korea, Philippines, and Vietnam. And but these pre-construction projects are not really certain, with many having sat in the pipeline for months, if not years, obviously due to the pandemic. So here are just examples of three wind tower structures. So as you can see, the top section with the blades are pretty similar. They can be from 80 to 120 meters tall, with diameters ranging from 1.5 meters to 3.5 meters. They of course taper up as they go higher. Each tower can have about 2 kilometer length of wells for inspection. Here's an example of a wind tower production plan view of the facilities. And as you can see, entity inspections need to be carried out at different stages of the production, from the growing stations to the joining stations, to the LSIM stations, and of course the repair stations. So keeping pace with production is definitely critical. So let's talk about the inspection strategy. So this is what a typical well configuration and defects would look like. It's typically a V with a narrow groove. You can see over here that the vertical angle for the radius is only about 8 to 16 degrees. So we will need to look for defects such as lack of fusion. They're oriented in the bevel portion with the lower fuel angle. You have the root area, so that's the back gouge section. You got the fusion defects in the J-pass radius, and of course the typical cracks in the OD and ID section of the wells. So multiple NDT techniques have been developed and used over the years, and the most common one over the decades was radiographic testing, or RT, and this has been the primary non-destructive testing used. So you can see over here. However, there will always be limitations, such as it can be less sensitive to tight lack of fusion. There are issues with the challenging bevel configurations or one-sided straits, etc. You can miss fusion type of defects, and you do not have any kind of volumetric information. And of course, For thicker wells, RT can take maybe even up to several hours, whereas comparing with ultrasonics or advanced ultrasonics like phase array, you can have instant results. So why ultrasonics? The main reasons include you can have improved productivity, a faster setup time, faster scan time, no production interruptions. So UT and PA equals to more scans in a day. So phase array allows us to perform numerous scans simultaneously, and we are able to cover the whole region of interest by electronically steering and focusing the beam to the incident of the well at various angles. So this not only decreases the speed of inspection, it also increases the effectiveness of the inspection by able to detect the defects aligned in any orientation, which might not be detected by conventional techniques like radiography. One of the most important features of advanced UT is that we can electronically steer and focus the beam, and which allows us to have an improved capability to scan and detect discontinuities located in regions even with limited accessibility. So the effectiveness and reliability of the NDT systems is very critical for the safety and the inspection. Over here is a supplementary technique, another advanced UT technique that we also employ together with phase array is time of flight diffraction. So time of flight does not depend on the defect orientation. So we can have a higher POD to improve the risk reduction and calculation. So over here is an example of a phase array and TOF working together to give us better detection capabilities and more accurate sizing. And over here is a screen showing using well site for phase array and TOFD, so we can have several volumetric views, and this gives us easier interpretation, and we are more confident for the results. So advantages, of course, for phase array and TOF inspection include we can scan way faster with phase array compared to single probe conventional UT systems, and we have full coverage of the well. Flexibility, setups can be changed very quickly depending on the components geometry. We have inspection angles, a wide variety that can be used depending on the requirements and of course the probe and array. We have also the advantage of a small footprint. So for depending on the situation, we can use even the small metric arrays, and then this can give us a significantly more flexibility than conventional probes for inspecting the restricted areas. And of course, finally, with advanced UT, you have imaging that shows the true depth of the image. So you would actually get a more 3D image and measurement of the well as well as the indications. Okay, next we're going to talk about what Olympus offers. Okay, first of all, what are the typical system requirements? It can be either manual or motorized inspection systems. We also need a linear phase array, shear wave probe for the well inspection. You might need more than one or two probes based on the thickness and the scan plan, of course. And you probably also need a 0 degrees for the parent material inspection. And you also can include in TOF, and depending on the thickness again, you might need one or two probe sets. So one solution, of course, is to use the OmniScan. And over here, we can be connected to the well site software to control the instrument. And you can have different scanners from manual to semi-automated. So here is an one of our offerings, which is a fully automated inspection card. This fully mobile solution is actually run using the Focus PX and well site software. So this offers a pneumatic arm and a motorized inspection head to offer stable and flexible inspections. And it's a highly productive solution because it's pretty automated. So in one scan, you can get 100% of the well, and very repeatable, of course, because you have a robotic arm over here. And it comes with a automatic well seam tracking system, and it can compensate for the well seam wandering of plus minus 25 mm. Our next offering is the column and boom system. This is, I think, a little bit more traditional. It looks very similar to the auto welding system, where the scanner arm is connected to the boom and the tube is on the rollers and it just rotates. This is typically designed for the circumferential wells. Again, very similar as the previous offering. And with this solution as well, we can connect it to the Focus PX or even the OmniScan today and run it with well site. Our third offering will be a robot on rails. So this is actually a semi-mobile solution where the scanner is mounted on a rail to inspect the well across the production line. There is a pneumatic arm and motorized head inspection mounted on the robotic arm. It's virtually infinite archive of different inspection programs, meaning that we can actually have different position of C seams and L seams to be configured easily. And again, it comes with an automatic well seam tracking solution, which we will show more on in the next slide. Okay, so you can see this is just an example of how our well seam tracking solution works. So it's laser guided, and it will actually track based on the well cap to do during the inspection. It can actually move at about 100 mm per second. Okay, next up, we actually have a fully automated robot. So this is a autonomous system with safety sensors to avoid unexpected collisions and just requires remote supervision. So there's a cobalt arm with the phase array top probes and TOF probes mounted on it on the scanner, and it can actually follow the well. And again, the inspection software on this guy will be run with a Focus PX and well site. Okay, so next is the comparison chart of the 4 solutions. You can see that we have a semi-automated crawler to a column and boom system to a robot on rails, as well as a fully automated robot. And depending on the requirements for inspection, we basically offer a solution for every kind of situation. So the common thing that ties all the inspection solutions together is that they are all controlled by well site. So well site is a PC-based software which offers powerful well inspection features, advanced analysis tools, and fully customizable displays. The workflow is designed to comply easily to ISO requirements. The optimized workflow can improve the settings and reliability. There is an embedded scan plan, definition tool, and ray tracing visualization. We have a predefined well profile, and there is unlimited file size, which allows the inspection of components with very large diameters in single files, meaning that the only limitation would be the size of your hard disk. So WellSite provides powerful analysis views. You can have the scan merge views, ABC scan, defect tables, TOF analysis display, and as well as 3D rendering of components and data overlays. So from the scan plan to reporting, you can perform inspection jobs from start to finish using WellSite on your computer and incorporate all data into professional reports using a customized Excel spreadsheet template. And in the next section, I'll pass on to my colleague Prasan, and he will give a live demonstration.
Thank you, Dennis. Good afternoon, everyone. So in the interest of time, we have pre-recorded the demonstration. So let me share my screen. Okay, so as Dennis mentioned in his previous slides, so over the systems which we offer, from a simple portable solution to the robot on an HGV. So the one common thing is a powerful WellSite tool which controls both the equipments. So it can be either used in combination with an OmniScan X3 or with a Focus PX in order to generate, perform your inspection until you're reporting. So in this demonstration, we will be using the WellSite in conjunction with OmniScan X3. So let me play the video. So we have a WellSite Remote Connect app, which is used to connect between, which acts as a bridge between WellSite and our X3. So basically, we just use an Ethernet cable to simply configure the IP addresses of the equipment, and the launch configuration tool on the WellSite used to detect and troubleshoot any of the errors in settings. So as you can see here, my X3 is directly detected, and I'm able to configure the IP addresses. So once it's connected, the X3 now can be used as a black box, and all the controls can be taken over from WellSite. So starting with the scan plan. So the beam tool has been embedded directly into the WellSite, and you can directly open your scan plans and all the groups, your different multiple groups of sectorial scans of face area, and also TOF can be automatically read by the WellSite. So the setup, the time it takes for you to perform the setup is similar to the time it takes for you to make your scan plan. Okay, so we can see all the probes, all the settings, including the gate settings, can be set and directly imported onto the WellSite. So once loaded, we can toggle between the different groups or the beam sets that have been created for all the four groups of face area on two sides, and also the top 60 degree what we have set. Okay. Next would be the probe and wedge verifications. So under the calibrations, we have one click checking for our probe and wedge. So as you can see here, we have a dead element, and we can set the tolerances and the deviation in which the WellSite will directly fire the single elements and give you the statistics and the status of the elements. So you can also individually check using the A-scan what amplitude every element is being fired. Same way, we can also perform the verification for the wedge. So we can define what is the tolerances in the element height and the wedge angle. And based on this firing, it will automatically calculate and give us the results of the status of the wedge. So it is a very quick tool before inspection to check whether you have all your accessories and probes and accessories in a good shape. Okay, so as you can see, you don't need to put it on any block, it directly fires it. So coming to the wedge delay calibrations. So the process is quite similar to what we have in our conventional or portable solutions. So we can use either target or side drill holes to capture an envelope for the radiuses of the side drill holes, and we are able to calibrate within the tolerances which we have set. Okay, the process is quite fast. Coming to the sensitivity calibration, so we can either do a manual calibration or the automatic calibration. So manual meaning we take individual side drill holes and get the envelope for all the elements. Okay, so we can see the points at which every angle has been captured. So using using WellSite for doing these calibrations makes it much more easier because of the faster refresh rates based on your computers and everything. But we also have a status bar. So once the calibration is within the tolerances, what we have set, which is the 80% plus 1 dB of tolerance, we can see the status bar changing into green. The interesting feature of the WellSite is a multi-point TCG. So typically we do more than at least 3 points for our TCG to cover the entire range. So WellSite allows you to perform all the 3 at the same time. So in this example, we are trying to set 3 calibration points. So once we set the target points and prepare to calibrate, you can see on our scan, so there are 3 gates that have been populated. So these 3 gates can be used to simultaneously measure or simultaneously capture the indications coming from 3 of our reflectors. So we simply put our gates on the 3 reflectors which we have chosen, set our gate to cover the entire range, and we can start capturing our envelope. Okay. Clear the envelope, and as we move, as you can see here, all the gates are capturing simultaneously, and you can also see the corresponding envelope on the right. So we can go until 12 points, and the system is able to simultaneously capture for all the 12 points. Okay. So we capture, and you can see here, the system automatically cuts off based on the range. So as you can see, the 3rd point, we don't have enough range to cover for all the angles. So it is only considering until angle 56. So once we hit the calibrate, we can re-verify our signal. And you can see all 3 are simultaneously, the gains are adjusted, and it is compensated for that attenuation. Okay. So we can double click on the scan and re-verify. Give me a second. Yeah. So this also helps you to complete your TCGs much faster, but also we have the manual TCG, which is the regular way of doing it. So instead of taking all 3 points at the same time, we do it one by one. So let me just fast forward it a little bit. Okay. So it gives us much flexibility to choose which points have to be calibrated. So you just need to uncheck them, and the remaining will be is the one currently calibrated. So now you can see there's only one gate, and we simply capture for that particular point and add the TCG. So it is much similar to how we do it in the portable solutions one by one. Okay. So we calibrate the TCG point and re-verify. So once the first point is done, we can uncheck it and go to the next point. So just move your cursor gates onto the reflector, and we are able to, as you can see, the gates are quite dynamic. So as you move the gates, the envelope is updated at a very quick rate. So this also helps you to, so it doesn't matter whether if you have set your gates properly or not. So once you have collected your envelope, you can always go and change your gate so that the right amount of indications are captured properly without, if you have any indications coming from the edges or anything. Okay, so we'll just quickly re-verify for the second one, and we can go for the third one. Just quickly forwarding it a little bit. Okay, so similarly for the third point, we can dynamically change it. So the one more option what we have is to contain the angles which are not needed. So as you can see, the higher angles over here has a very high amplitude, but they are very far away from our area of interest, which is our well volume and the heat affected zone. So in that cases, we have now the ability to contain. So you simply drag from your left to from where you want to contain it. Okay. So one more advantages of WellSite is you can have a better processing on your TCG. So you can simply export the TCG points, and you are able to re-export. So we also have seen how we can customize our layouts. So it's as simple as just drag and dropping various available views like your A scan, your B scan. We also have our corrected scans and the remap scans. So here we are just using our S scans and A scans. As you can see, the both groups on the 90 have already the TCG made. So we can simply export out those TCGs, and we can re-import onto the 270 side. Okay. So we can export and import on the TCG on the second group. So as you can see, the table over there is not populated. So as soon as we import it, we are able to see the table generated and also the TCG points on our A-scan. Okay, we can do the same for any number of groups based on the availability of TCGs which we have already created. Okay, so the overall making of your inspection setup and calibration takes a very little time compared to the conventional way. Similarly, the TOFD calibrations. So as you see here, when we choose the TOFD setup, the calibrations have been options have been changed to show the ones which make sense or which are required for TOFD. So we can either calibrate wedge delay, PCS, and velocity. So here we're using a 1-inch block to calibrate, and you can see as soon as we hit calibrate, the readings on the right have been set to the dimensions of the block itself, the lateral wave at 0 and the back wall at 25.5. Okay. So these cursors are used both for calibration and also for your measurements while doing your analysis. So going forward, so we also now coming to the data collection. So once everything is set, we have numerous ways in which we can configure our layouts. We have complete flexibility on setting our references and also setting our offsets. We can also define the type of encoders which we have. So simply keying in the details of the length of the scan and also the resolution of the encoder. If you have already calibrated it or if you're using it for the first time, you can just key in the resolution. So when we are doing phase array and TOF together, the main thing to make sure is in order to match for the readings or the datum points, we need to adjust our scan offsets based on the actual positions on our scanner or the inspection head. So for individual groups, it is quite flexible to change it. So as you can see here, we are setting it to 120, and we can see later, the B scans are adjusted accordingly to show the data captured simultaneously, but some also adjusted in order to display at the right positions. So we are able to achieve higher speeds even with the wide range and many angles. So as you can see here, our phased arrays are starting at a negative 120, which is the offset, and the TOFD is starting at 0, which is our start position. So the acquisition rates and the refresh rates for our A scan and B scan are quite fast, even though we have like 5 groups. So as you can see, the software state on the below keeps on changing based on what we are doing. So initially it will be in setup. Now it is transitioning into analysis. So once we stop the data collection, it automatically moves into data analysis. Okay, so for this part of data analysis, I will do it live with you. Let me reshare my screen. Excuse me for a moment. Okay, so I'm using the same data which we have captured just now. So as you can see, we can have any number of preset layouts saved, and it is as simple as just dragging and dropping the different views. So as you can see, we have our all the necessary A scan, B scan, D scan. We also have the well gates, which is a special feature which is included in the well side. So what it does is it only shows the indications which are within the well and the heat affected zone. So you have complete flexibility over choosing or setting your pieces. So as you can see, I can simply change the heat affected zone and it will be automatically updated. Okay, so the well gate function is independent of any of the gates you set. It will only show you the data which is inside the well and the heat affected zone. Also, you can toggle between different groups and different views. So here we have the S scans. We can also toggle to the A scans. And we can also look at individual scans like this. Okay. So one more important feature what we have is the merging function. So as we move on to the phased array, so we can merge all our phased array scans together. And we can also re-import the configurations. Okay. Let's say you have defined this as a plate, but during analysis, you have the option to redefine it as a pipe by simply loading the piece directly from your beam tool. So merging our C-scans will directly give us projection views. So you can define what type of projections you would like to see. Okay. So we have our projected D-scan, C-scan, and side view, along with our polar view. Okay. Let me just hide the cursors for a while. So this gives us to a very useful and very easy to interpret views, which can be defined as a slices. Okay. And you can also have a corrected sizing over the length due to the curvatures using the polar view. Okay. So we also have a 3D model included inside. So the data will be configured or remapped onto the 3D view. So you have a lot of functionalities which you can edit in order to see your data. So going back to the different views what we have. So this will be helpful for us to do our sizing. sorry. Okay, so let's say we are just focusing on the face array right now. So we have an automated tracking function. So as you move your data cursor, the data angle cursor is automatically, sorry, okay, you have the tracking function. Just sorry about that. Yep. So as I move my data cursor, the angle cursors are automatically tracking the highest amplitude, and we are able to see a very clear indications in our B-scan. So once we have the indications, sizing and reporting is quite simple as well. So we can simply activate our indication table and also our measurement and reference cursors. So I'm just eyeballing the ends of it. Okay. Similarly, you can get the height from our scans. Okay, and we simply add the indication. The same thing we can do for the other indications inside our well, which we have just scanned. Okay. So you can have this either this cursors linked or it can be moved independently. So once you have all the indications already pre-selected and defined in the indication table, added an indication, you can simply export out the report. Okay, so report functionality on website is a complete top to end customizable process. So you can replicate whatever existing report formats you have by just simply editing the template what we provide. So when you have hit the report here, you have two, one PDF and one Excel sheet generated with all the information captured from your inspection setup. Okay, so let me bring over the Excel sheet. So you have also complete control over the reporting. So either you can select which pages have to be printed for your report, or you can also define your custom pages. So these are all co-managed pages, which all the information has been taken from the setup and your inspection and is printed out for you. So as you can see, if I bring out my Excel sheet, which we generate from website. Okay. So the individual pages, what we have seen on our website, individual options, what we have seen on our website is the individual pages inside our Excel template. Okay, so we have a cover page and it has a lot of metadata which can be used to customize the entire look of it. So some of the information is directly tracked from your from your inspection. You can also include some of the metadata which you can map to wherever in the Excel sheet you need. So the component piece, all the definitions have been imported, and you have a location where you can have where you can keep the actual photos or diagrams of the job you have performed. So similar with the equipment. So all the equipment details is pulled through. And you can also see the scan plan. So here, since we left this open because you have many different groups in the same setup. So having one picture taken might not portray the right information what we are trying to give in the report. So it has been left open for you to reconfigure and just paste the image over here. So for every individual groups, we have all the information of the probe, our wedge, where is the offset, what type of UT settings and the focal loss what we have generated, and also including our gauge settings and the TCG. So this is set for, so let's say if you have 6 groups, you have 6 individual pages. completely defining all the information of your settings. We have a page dedicated for all the settings in your scanning, like our encoder settings and everything. So all the information which you typically have in your report, everything is directly taken. So by simply defining your indications and performing your inspection, everything else has been taken directly from the setup. Okay. So as a summary of an inspection, you have a page where you can have the image drawings and everything. And we also have our image indications. So this individual image indications portray all the information what we have captured inside the indication table, and also it directly takes a screenshot of where you have captured this indication. So for all the indications, we have individual pages detailing the information and also the screenshots. And at the last, you also have an indication table. So you can also configure or customize what information you want to show. So if you go back to your well site, so you have all this information, you can toggle on and off of what you want to see actually in your inspection reports. So it's not just bringing out the information of what you have. You can completely replicate the same reports what you have been doing. So with a couple of effort in replicating and remapping your information, various information from different locations, you can able to produce repeated and consistent reports. Okay, so not just in the phased area and TOF part inspection where you have a dedicated features to help improve your productivity. We also worked on having a highly productive reporting function. So that brings to the end of our presentation. If you have any questions, we'll be happy to answer. So you can either type in the chat box or you can raise your hand.
Okay, so there's actually one question from asking, is inspection of wind tower turbines carried out only during manufacturing? How about towers that are in service? Do they require inspection of wells? From our experience, we do have service provider customers around the world that are doing in-service inspection for the towers. Of course, these are up to the wind tower farm owners. Okay, there's another question. Is this a new software for phase array and TOF? Well, WellSite has been around for the past few years. It was mainly deployed for the Focus PX, which is a rack mount system. But today, you can also use it with the OmniScan X3. One more question was, is this a software like the Pipe Wizard for AUT? The Pipe Wizard software is actually a very specialized software specifically for long distance pipelines. So it's a little bit different.
So we have one more question from Suresh. So is there any major wind turbine manufacturers already using the software for inspection? Yes. So we have supplied. So as Dennis showed in his presentation, right, we have multiple options. So depending on the protection and depending on the budgets, we have supplied different inspection options. So and all these options work on the same well-site software.
Okay, so there's a question from Scott. Can the flange weld be tested using this setup? I guess it depends on if just like for any UT testing, right? You need the space to put the probes. So if you want us to dive into this, maybe you can contact us after this webinar and with information on how the well is going to look like on the flange, and we get back to you. There's another question, which is you want to know more about the acceptance criteria of well for the wind towers. So far we've seen that the wind tower wells are mostly based on the ISO standards. I can't remember which code is it exactly, but it's out there, one of them. So probably if you search around or you contact us after this, we can get back to you with more information. Okay, guys, any more questions? Okay, there's a question from Mr. Jeffrey asking, can this software be customized? Is that what you're trying to ask? Well, depends on what additional features you need. So we are always trying to improve our software, and we take all our customers' requirements and needs seriously. So just talk to us. So well site today is not the same well site like it was the last year or 2 years ago. We definitely are working on improving the software as much as possible to fix all the bugs, as well as to input all the features that inspection clients require today. Okay, another question from Suresh. Do you need to remove the surface paint if you want to do inspection on turbines? Well, as with inspection of any steel or even composites, as long as the paint is has good bonding on the surface, you probably don't need to remove it. So I guess this will be a question for in-service, right? Yeah, again, just like any thickness measurement, for example, if there's paint is bonding, you won't be able to send your signal through to the base material, right? So if the surface is good, bonding is good on the paint, you probably don't need to remove it.
So we don't see any more questions. So we will be ending the session here today. Thank you very much guys for joining. So if you have any further questions, or if you're further interested in knowing in more details, feel free to always contact us. So you'll be receiving a recording of this video if you want to rewatch the webinar on the demonstration. On behalf of Olympus, we thank you for joining.